All right, here's where the rubber meets the road. We are going to solve systems with three variables. We need three equations to do that. And so we're going to dive in. Now, with these in this particular video, we're going to pretty much just use elimination as our primary method for solving these. You can use other methods. You can actually use substitution to solve them. You can use, well, we are going to learn a couple more methods in some future lessons, but excuse me. In this particular video, we're going to use elimination as our main vehicle for solving it. So we've got three variables, right? We've got X, Y, and Z. We've got this graphed on a three-dimensional axis, something like that. I don't know. Did a terrible job. We're not worried about that, but it's the same. So the solution is the same thing, but instead of being an ordered pair, we're going to have an ordered triple. So it's a individual point where three lines in 3D space cross, okay? And going back to normalcy. So we're going to start by working on eliminate a variable. Now, our goal, we're going to ultimately eliminate the same variable on these things. We're going to put two equations together and eliminate one variable, and then we're going to put another two equations together and eliminate the same variable. And it's very important that you do the same variable, because then we're going to end up with a 2x2 system, and then we can solve that through the method of our choice. So let's start. Let's take a, you kind of got to look and see what you feel like is going to be the easiest way to go. I'm thinking that the y's look like the easiest, especially since this one's got a 1, right? It's going to be easier to make it match other things. So let's first take these and let's eliminate y out of equate. Let's lumber these just so for the sake of talking. 1, 2, 3. All right, that's a 3 probably. We'll say it is. All right, 1, 2, 3. So we're going to eliminate y. So we're going to take 1 and 2 together. 1 and 2 together. And we're going to eliminate that y. So I'm going to rewrite it. Rewrite this first one. So 3x minus 2y. I'm writing a little bit smaller than I usually do. I'm hopefully gonna fit as much of this problem on one page as I can, because it's gonna be easier for you to see if it's all together. But I may end up having to cheat and go to a new slide, if you will. But we'll see what we can do. So equals 35, and then we're going to get our second one over here, which is negative 4x plus y minus 5z equals negative 36. All right, we're going to eliminate the y. So in order to do that and make them opposites, we would make this one a 2. So we're going to take, excuse me, and multiply this second equation by 2. All right, so that's going to turn into 2 times negative 4 is negative 8x plus 2y minus 10z equals negative 72. Right? I'm going to go ahead and rewrite that other one below it just so that they're lined up and we can see what's happening. 2y plus 4z equals 35. So that's just that equation number 1 rewritten. So now I'm going to eliminate, right? So when I do that, these y's drop out, and then we are left with 8 minus 3, so that's 5x. And I may keep that shifted over. We'll rewrite it again here in a minute, but I may keep that shifted over just to make it easier to see what's happening. So negative 10z plus 4z is negative 6z equals negative 30 something. So we're going to subtract because the signs are different. So 72 minus 35. Keep in mind that the bigger one is the 72. So it's actually going to be negative 37. All right, so there's one 2 variable equation. So let's do the same thing, but we're going to do it with equations 2 and 3. Okay, so Let's do 2 and 3. So, equation number 2 is negative 4x plus y minus 5z equals negative 36. And then 3 is 5x minus 3y, excuse me, plus 3z equals 31. So again, we're going to eliminate the y's. It's got it on this first getting down to a 2 by 2. It's very, very important that we eliminate the same variable each time. So we're going to eliminate those y's. That's easy to do in this case. We just multiply this top one times positive 3, right? Because then go. Remembering that sometimes we do have to multiply. Oops, why am I doing it by negative 3? That's a bad idea. What do you think? How about times positive 3? Sometimes you do have to multiply both equations by something, right? We'll throw that out there as a reminder. Okay, so 3 times negative 4 is negative 12 x plus 3y. Negative 5z times 3 is negative 15z equals, I don't know if I can do that in my head, 36 times 3 equals 108. I know, you're all right. Come on, Sean, you can do it. Why can't you do that in your head? I don't know, folks. I can't do it. I'm not a real math teacher. I know. That just is probably true. Then we're going to eliminate. It's going to kill the y's. 5x plus negative 12x is negative 7x. And then 3z minus 15z is negative 12z equals 139. 39. Okay, so now we have two variable equations. So that we already know how to do. So let's write those and solve those. So now we're going to put 5x minus 6z equals negative 37. Excuse me. And then this one over here. So negative 7x minus 12z equals 139. Right? So let's eliminate the z's. That looks easy because we just multiply this one times negative 2, and then we're in there. Easy peasy. Top one times negative 2. So negative 2 times 5 is negative 10x. Negative 6 times negative 2 is positive 12. And this is a z. Equals negative 37 times negative 2 is positive something. 37 times 2 equals 74. 74. Okay, so then we're going to eliminate right there, which is going to cancel those. Negative 7x plus negative 10x is negative 17x. 139 plus 74. 139 plus 74. Oops. 139 plus 74. There we go. Did it that time. Is 213. 13 divided by negative 17. It's going to give us a negative as the answer. Won't worry about putting that in the calculator. We'll just remember our signs to keep up with that. So that divided by 17. Enter. Oh no. So I figured out what it was wrong. Figured out the mistake. Mistakes happen. This should have been a negative 108, which would make this not 139 at all. It would in fact make it negative something. Let's see, 108 minus 31, 108 minus 31 equals 77. So this should have been negative 77. This should have been negative 77, which would make this different right here. It'd be negative, what is that, 114? Check my notes. Does that sound right? No. I don't know what happened, but this should have been 74. So I don't know. I don't know where I did that wrong, because 37 times 2 is 74, which I may have had. I did have. I had it positive. I don't know what happened there. I think I erased something wrong, or I confused myself because I was irritated that I made a mistake. Happens to the best of us and the worst of us all together, all the same, all the things. Oh my gosh, guys and gals. This is why I shouldn't make videos late in the evening. Negative 2 times 5. No. What? Should that be negative 5? Should that have been negative 5 all along? It should have been negative 5. So I'm leaving all this in here, and I'm going to tell you why. Partially, I'm tired, and I need to get this video out so students can watch it and all the things. So that's part of it, right? This should have been negative 5 because negative 8 plus 3 is negative 5, which makes this negative 5, which makes this a positive 10, which makes this a 3, right? Because negative 7 plus 10 is 3x. So this is going to be negative 3, right? So as I was saying, another reason I'm going to leave this in here is because this right here, what has happened to this terrible video, and with all these just small mistakes, wasn't because I didn't know what I'm doing. When you make mistakes on these, it probably won't be because you don't know what you're doing. It's probably because you made a little mistake, and you need to check your work, and you need to do a good job checking your work, and all of those things. When you get an answer that doesn't make sense, you should really check your work. But the real reason is because this is kind of a PSA for when we learn Kramer's rule later. If you use Kramer's rule, because see this, I made a little mistake way back over here, and then another little mistake over there, and that would ripple over, and it would make and my whole answer would just be up in smoke because I made a little mistake. Like just a copy mistake early on, it just breaks everything. But if you use Kramer's rule, you'll learn later that we can make one small mistake, and it only breaks part of the problem instead of all of the problem, and you can still get part of the answer right even. But anyway, all that to say, this video is not going to be too terribly long anyway. We're just nearly done. So we have a value for x. So what can we do now? Well, of course, you probably already figured this out. We can take and substitute this back into one of these two variable equations. Let's put it in this first one. I don't know, they're all kind of ugly and whatever else, but I think that seems like the easiest place to put it. So let's go ahead and put it right there. We're going to put it in for x into this one. So negative 5 times negative 1 minus 6z equals negative 37. Negative 5 times negative 1 is 5 minus 6z equals negative 37. We've got to add 5 to both sides. One more. I shouldn't make videos in this late in the evening. This is clear, but sometimes we got to do what we got to do. So how about subtract 5 from both sides? Negative 6z equals negative 37 plus negative 5 is negative 42. Divide by negative 6. You know, my brain is telling me that's an easy math fact to do, and you should totally just do that in your head. But honestly, as wacko as this has gone, I'm going to stick that in the calculator and double check that 42 divided by 6 is in fact oh my gosh. 42 divided by 6. I hope y'all have laughed some. I don't know that I have, but I'm going to be laughing when I stop this recording and upload the stupid thing. 42 divided by 6, what's going to be the punchline of is in fact 7. Well, it is. Negative divided by negative is a positive, so it is z equals positive 7. We're almost to the finish line. What we can do now is we can plug this guy and this guy into any one of those guys. Let's pick this last one. Why not? So we're going to take and plug it in. So x, so we're going to put 5 times negative 1. I'm plugging this in equation number 3 here. Minus 3y plus 3 times z, which we just found out is 7, equals 31. 5 times negative 1 is negative 5. I'm going to hope that that's right and I didn't make another mistake. Is that right? I don't know. We're making a mistake counter. Probably should. 3 times 7. Again, that's an easy math act, but we're going to punch it in the calculator just because of the nonsense in this video so far. 3 times 7 equals 21. Of course it does. You knew that. I knew that. What are you talking about? Equals 31. We got some like terms over here. We're going to combine those like terms. Negative 5 plus 21 is positive because the bigger number is positive. Positive 16. Honestly, I'm putting that in the calculator. I'm doing it just because we're not making mistakes anymore. We got this. Plus 21, 16. Yay, good job. You did it. Good. It's going to be okay, y'all. It's going to be okay. Someday, eventually, I will remake all of these videos, but not today. So we're going to subtract 16 from both sides, minus 16, minus 16. So that gives us, I'm going to bring us up to here. That gives us negative 3y. We're going to chance it. We're going to do it. Negative 3y equals 15. We're chancing it. Is that right? I don't know anymore. Divide by negative 3 and divide the other side by negative 3. Y equals negative 5. We're going to write our answer as an ordered triple. X is negative 1. Y is negative 5. And Z is 7. Does that match my notes? Yes. Yes, it does. And that is it. I remind you, if the variables disappear on a problem, then it can be either no solution or it could be all real numbers. If it comes out true, it's all real numbers. And more likely, especially in a 3x3, if it comes out as a false statement like 0 equals 15, then it is no solution. That's it for this lesson. If you're one of my students, you can make fun of me about this lesson in class. It's fine. I can handle it. If you're not, you can make fun of me in the comments. Don't be too mean. I might cry because of strangers on the internet. I will see y'all in the next one. Adios. Bye-bye.